Who is this?
That's the guy from Despicable Me.
Despicable Me 1, yes, the guy. Let's get a name.
Is his name Victor?
His name was Vector, right? His original given name was Victor, but he changed it to Vector. Now, the bigger question is, why? Who just joined me? Somebody just joined online. Who is it? Gosh darn it. Gotta figure this out. Obviously this is Vector. Now, why did he change his name? What did he say?
Didn't he want to be more villain?
Yeah, but he committed crimes with what?
Magnitude?
Yes. He committed crimes with both magnitude and direction. Oh yeah. You're right. Yeah. You knew I was going to do that. It's funnier when he does it, but yes, we definitely need to understand what those two words mean, because that was his catchphrase. These two things are extremely important. When we draw a vector, we use an arrow. Okay? The arrow has what we call an initial point. And it has a terminal point right at the end. Now, yeah, I hear you typing. You think I can't hear you, but I can hear you. Now, some of you will do something like this, and I don't want you to do this. I don't want you to extend your arrow past the terminal point. We call it the terminal point for a reason. So don't make your arrow go past your terminal point. It must stop at that particular spot. By the way, for those of you wondering, I did decide to change the due date on the Math Excel 6.1. I was going to have you finish it before vacation, but I know that some of you are going to put your minds near some very large magnets and try to erase everything that I'm trying to teach you today. And so over this next week plus, you'll tell me things like, I don't know what any of this stuff is on vectors. Well, so when we get back on the Tuesday after break, so my intention is for us to maybe start the Math Excel today, but not necessarily finish it. Okay, so if we get through all these notes, and it'll take me about an hour to go through these notes, you can start on the Math Excel, but don't think you have to finish it. When we come back on Tuesday, I expect us to get back into this and finish that Math Excel, so that would be some good problems to review with. Anyway, that was a nice commercial interruption. Just so you're aware, the 60 minutes today, maybe a couple problems in Math Excel if you get to it, but unless you're just diehard and you want to get it done, otherwise just wait till we get back for the rest of the Math Excel. Okay, so what's the magnitude of a vector? The magnitude of a vector is the length of the vector. This right here is called the magnitude. So it's basically the length. Now, is there any way in the world you can tell me how to find the length of the vector, since it is the hypotenuse of a right triangle?
The Pythagorean Theorem?
That's exactly what we would be doing, the Pythagorean Theorem. Now, we will be talking about these two sides. Why did I label it A and A? It should be A and B, for crying out loud. A and B. We will be labeling our vectors with what are called components, and those components will tell you which direction to go to find that particular vector. Now, when we write things in component form like this, we are assuming that the initial point is 0, 0. Now, that's not always true for every vector, but when we write it in what we call component form, these are both called the components, the A and the B, but when we write it in component form, we're basically saying that we're starting at 0, 0. And we'll see that when we draw pictures of it. But the direction is the other part that he mentioned, and the direction would be the angle measurement. The angle measurement as measured on the unit circle. If we drew a big circle around this and, labeled this 0, and up here would be 90 and so forth, we could talk about that. Now, how would we find the angle inside that triangle? Let's see here. Is it so or ka or toa? Which one of these would we be dealing with to find the angle?
Wait, what angle are we looking for?
We're looking for this angle. I'll call it theta.
Okay.
You've got B and A.
Be opposite and adjacent.
Yeah.
So it'd be tangent.
That's right. So theta, the direction, will be calculated so theta would be calculated by doing inverse tangent, y over x. Now the direction, we'll actually have to draw a picture in order to figure out the direction. And I'll explain that later. But you're going to have to be able to draw these vectors and know which quadrant they're in, because otherwise you won't know or how to tell me what the direction is. Obviously the one I've drawn here is a quadrant 1 angle, so that should be a piece of cake. If I go too fast for notes and you need something back on screen, please just yell at me and let me know. So I kind of already mentioned the idea of, here, let me just zoom in on the pictures here. I kind of already mentioned the idea of a terminal or initial point and a terminal point. We would draw our vector from here to there and stop right there. And you could, just like I did before, look at this as A and this is B. And that's how we find. We use this kind of cool notation with these symbols on the sides. This is going to tell us that it's a vector, as opposed to just a plain old coordinate in the universe. So they kind of look like less than and greater than symbols. The most boring vector in the world is the 0 vector. That's right, folks. It is a vector 0, 0. Gosh darn it, that's pretty short. It's a dot, folks. Not even sure what direction I would call that. All right, sorry, that's only funny to math teachers. Okay, so moving on. This is, now vectors, as I talked to you before, do not have to start at the origin. They could start at random spots and end at random spots. And we should be able to figure out, if we know that it's the terminal point minus the initial point, so if we do the terminal point here, let's say we're going to do this one right here. That would be, so negative 1, 6 minus negative 4, 2. So what's negative 1 minus negative 4? Negative 1 minus negative 4. Anybody out there in TV land?
Negative 5.
Nice try.
That's 3.
That is 3. Thank you very much, right? Because the double negatives cancel out and become a positive. All right? But I do thank you for playing there. And then 6 minus 2, that should be easier. 4. So this particular vector has component form 3, 4. 3, 4. And if I zoom in here, you'll see a little bit better in the picture what I mean by that. If you were to kind of envision or imagine that the initial point is the origin, then you could go 1, 2, 3, 1, 2, 3, 4, and you would arrive at the terminal point. So there's my vector 3, 4. So some of you are probably asking me, saying, well, if the numbers are small like this, can I just count? Yes, you can. If the numbers are weird, then no, probably not. But this one is also the vector 3, 4. These are called equal vectors. They don't have to start in the same place. They don't have to stop in the same place. But you can see that their components are the same. If the components are equal, then the vectors are equal. Now, is this vector that I'm drawing in the red in the bottom left, is that vector the same as this vector? Are these identical vectors?
No.
No, they are not. Now, what they do share is they both have the same magnitude. But that's all they have. They do not have the same direction. So, in order to be equal vectors, they must have the exact same components. And that's extremely important. Okay, so none of what I'm showing you here is, oh, why does this have writing all over it? How is it blank notes if it's got writing on it? Hold on a second. Okay. Now, the top part is something you've already seen. Now, what you haven't seen is this notation right here. So maybe I'll talk about that. Vectors a lot of times will be written with lowercase letters, and they're written in bold. Or you might see a notation that looks like this. So if you see any kind of lowercase letter with like a half arrows type thing written over the top, that's a vector. When they put the absolute value bars around that, that's referring to the magnitude, which is your good old Pythagorean theorem. So nothing complicated about that. Same thing we already talked about, but the notation of finding the magnitude is with the absolute value bars is something you might be unfamiliar with and would probably confuse you. But it's kind of like absolute value for the number line too. Find the magnitude of the vector represented by. Okay, so they did not give it to me in component form, which would have made my life a lot easier. They gave it to me in initial point and terminal point. So when you look at this, can you tell me which point is the initial point and which one's the terminal?
Is P initial and Q terminal?
Yep, that's right. This is the initial and this is the terminal one. And it goes along exactly with what you guys learned in geometry class about rays. The only difference is a ray goes on forever and ever and ever, and a vector has a stopping point. So if we take the terminal point and we subtract the initial point, terminal minus initial, what is -5? Take away -3.
-2.
Yep, we got a -2, and 2 minus 4 is also -2. So this is where I'm talking about. It's very important that you be able to draw these. Which quadrant is that going to be in? -2, -2. Is it 1, 2, 3, or 4?
3.
It's got to be in 3, doesn't it? 2 left and 2 down. I recommend that you draw that terminal point and then connect it back to the origin and then put your arrow on it so that you know you haven't gone past the terminal point. Now, how do I find the length? Because they're asking me for the magnitude. Oops, can't spell magnitude. I can't even spell the abbreviated form. That's ridiculous. Magnitude. Okay. What are we doing? If you don't...
Finding the length of the hypotenuse.
That's right. So we got a -2 and a -2. The negatives don't matter because you're going to square them anyway. So that'd be 4 plus 4. And that would be the square root of what big number? Okay, I'll do it. 8. Now, I am not interested in you simplifying the radical. MathExcel might be interested in you simplifying the radical, so MathExcel might expect 2 radical 2. But that's why it's important when you're doing a test for me that you snap pictures of your work and you upload them to the Google form so that I can immediately open it. We will have a Google form for you for the next test. Or if you do a retakes, which I'm sure many of you will do retakes after the break for 5-1 to 2 and 5-3 to 4. Although some of you did really well in the 5-3 to 4. You might just want to do the 5-1 to 2. That's fine. And you can do both if that's what you choose, one time. But if you want to simplify the radicals, you can. I'm not requiring it. Now, MathExcel will probably tell you you're wrong. So if you're doing homework and you just want to get an 80% and you're getting close to the 80% mark, then make sure you simplify the radicals so it's happy. Okay, so that takes care of that. Now, if we talked about how to find the direction, they didn't ask me that in this question, but let's just suppose I did that because we're trying to find the angle that's inside the triangle there. And we do the opposite divided by the adjacent. What do we end up with? If you got your calculator, make sure it's in degree mode. And what are we getting when we invert the tangent? I'm going to start unmuting some mics here.
45.
Yeah, 45 degrees. Now, that is not the direction, but it will help me find the direction. Let's think about this. 0, 90, 180, and it's even past 180. So your answer better be higher than 180 degrees. So what are you going to do with the 45?
Subtract it.
Well, what would you subtract 45 from? I don't think that would be the best decision.
Would you subtract it from 270?
You could. Now, that's a slippery slope you start getting on because not everybody can follow the logic of what you just said. So I would not recommend you start doing things from the vertical axes. I would recommend that you stay with the horizontal. So if we know that the distance from here to here is 45, I would just take the 180 and add the 45 to get 225 degrees for your direction. So,
okay.
Now, what if we had been up in quadrant 2? What would I have done with the 45 degrees then? I probably would have... I would subtract it from 180. Okay? What if I was down in quadrant 4? I would have taken that 45 degrees and I would have subtracted it from 360 to find out that it was 315 degrees. What if you were in quadrant 1? What would you do with the 45 degrees?
Subtract or add it to 0?
Well, adding to 0, let's think about that. That means we don't have to do anything, right?
Yes.
Okay, so it's really important that you know which quadrant you're in, or, because sometimes you have to do something with that angle measurement, and other times you don't. So drawing the picture is important, and some of you that refuse to draw pictures end up, especially when you're doing MathExcel assignments, if you don't draw the picture or know what the picture looks like, it gets awfully confusing what kind of direction you should be having.
Wait, sorry, Mr. Staley?
Yep.
I'm still confused. Wait, so how are you supposed to know when you subtract or when you add the 45? Well, in this case, the 45.
Okay. So maybe I should just clear it off and draw another one. So pick a quadrant. Which quadrant do you want me to try?
Let's do 4.
All right. So suppose I was down in quadrant 4, and we had said that we were 2 there and 2 there. So you're talking about the vector 2, -2. Okay.
Mm-hmm.
So if we do the inverse tangent, y value divided by x value, it might even tell me -45 on a calculator. But the key thing here is that inside here is a 45-degree angle. But if you're trying to find this direction, the green one, then you're going to take the 360 and you're going to take away 45 degrees so that you can tell me that the direction is 315 degrees.
Oh, okay, I get that now.
Okay. That's why I'm saying it's really important that you know which quadrant you're in so you know what to do with that angle measurement. Otherwise, I mean, some kids every year want to tell, do I always add it to 180? I'm like, no, you don't always add it to 180. Do I always subtract it from 180? No. I'm like, you got to know which quadrant you're in.
Okay.
They want to memorize a way to do it every time, and I'm like, well, you need to look at the picture.
Okay, so basically depends on the quadrant. Then.
Yep. Totally.
Awesome.
Totally.
Thank you, Mr.
Yep. Okay, so when we add two vectors together, let's say we want to add 2, 5, and we want to add 7, 3. If we're going to add those together, guess what? It is really that easy. 9, 8. There's nothing complicated about it. When you're adding two vectors, you add the x components and the y components. Nothing complicated. Okay? And we call this the resultant vector. Now, another type of resultant vector would be to multiply it by a number. So like if I took 3 times the vector 2, 5, I would get a new vector. So the result of that would be a new vector, 6, 15. And yes, folks, it's just as easy as distributing the number on the outside to each component. What do you think happens to the magnitude if I triple a vector component, the vector components? What do you think happens to the magnitude?
It gets tripled?
It gets tripled, exactly. All right? What do you think happens to the direction when you triple a vector?
Does it stay the same?
Yes, exactly. It stays exactly the same. It doesn't move. It doesn't change. All you're doing is making it longer. Now, adding vectors together, that's a different story. We will totally get a different magnitude. We will get a different direction. Yeah, all of that, that's definitely going to happen when you are adding. I wanted to show you some pictures of what happens when you do add vectors together. Okay, so we've got vector u. Maybe I'm gonna write down some numbers here. Just let's call this 2, 4, and maybe vector v. We'll call this 7, 1. Now, what I have done here is I basically looked at it and said, okay, we're just estimating here, 2 up 2 and over 4. But guess what? I'm also trying to look at this and say, what if this were the origin and for vector v, and that would be over 7 and up 1. Now, when we add two vectors together, it's like we're gluing them end to end. And we're seeing the new result. The new result, this is your resultant vector. Now, why is this important? Well, suppose I'm flying an airplane, and I have a particular direction that I want to head with the plane. Okay, a particular direction and a particular magnitude that I'm going to be flying this plane at. Let's suppose the wind is pushing me this direction. Guess where I'm going to land if I don't take into consideration the wind? I'm going to land here. So, pilots have to look at the weather and have to gauge what's going on to make sure they're going in the right direction, because they have forces that are pushing on the plane. So they have to recalculate which way they want to go in order to make things happen. Now, the other picture that I have here shows you something different. So this is u and v. So right here, u and then v, that gives me u plus v. Well, guess what? This is v plus u. So v plus u lands in the exact same place. In other words, the resultant is the diagonal of a parallelogram. The resultant is the diagonal of a parallelogram. It's helpful to understand what the pictures look like so that you can kind of grasp what you're doing. Now, what do you think u minus v is going to look like? What will u minus v look like? Well, let's see here. So u looks something like this. Minus v is going to look like this. Now, how or why did I draw it like that? So we've got u and minus v. What happens when you multiply something by -1?
Becomes negative.
It becomes the opposite. And for us with vectors, that means it goes in the opposite direction. So this black one that I'm drawing right here is u minus v. So if you're an airplane pilot and you've got a headwind, you've really got to calculate something different so that you don't end up going the wrong way. I've also got some pictures here that show exactly what we've already talked about, so I won't go into too much detail here. When you multiply a vector by 2, you stretch it by 2, but its direction stays the same. If you multiply by a number smaller than 1, you shrink the vector, but it stays in the same direction. And when you multiply by a negative number, it goes in the opposite direction. And in this case, because it was -2, it was also double the length, but in the opposite direction. Okay, I don't think I'm going to go through example 3 because I think I've talked about it enough. Adding and multiplying are not difficult for you guys. You'll be fine with that. Same thing I've already talked about before. Okay, let's find one of those silent people out there. Okay, Miss Hamilton. Suppose a vector has a magnitude of 5. Suppose a vector has a magnitude of 5.
Okay.
Yeah, okay. Yeah, I haven't got to my question yet. Magnitude equals 5, and I want to change it to a magnitude of 1. What do you think I need to do to change something, to take a vector from magnitude 5 to magnitude 1?
Can you just multiply it by 1/5?
That's exactly what you would do. Thank you very much. Now, multiplying by 1/5 would be the same thing as saying we divide by 5. So, what they're trying to show me in this particular formula here is if you want to take a vector and change it into what we call a unit vector, that means it heads in the exact same direction as the original vector, but it only has a length of 1. If you want to do that, which there are times where we do want to do that, we will have to divide by the magnitude. So let's suppose we've got this vector 3, 2. First, we need to find its magnitude. And Mr. Barry, can you find me the magnitude of that? And Miss Graber, I want you to back that up and make sure that Mr. Barry's answer is correct. So, Barry and Graber, help me figure out what is my magnitude. Just doing the Pythagorean Theorem. And now I don't need a decimal.
Mr. Staley, there's
Yes.
something wrong with like your screen where you can't read the entire question. It's just like black squares.
At the top?
You got rid of it. I don't know what happened, but it just
Okay.
fell.
All right. Well, thank you for telling me. That was basically the manage participant window, so I could see the names of everybody online. So
Okay.
thank you for. I didn't know that happened. I didn't think you could see that box at all.
It was just like a plain black box with nothing in it.
Yeah. Weird. Okay, Mr. Barry, you got an answer for me? Is he out there?
I'm getting there.
All right. Well, let's see if Miss Graber beat you to it, and then you can tell me if she's right. Miss Graber, you got an answer?
No, Miss Graber did not beat him to it.
What?
Is it,
Come on, Pythagorean Theorem. What are you going to...
I know. So you do, would I just do 3 squared
Yep.
plus 2 squared, and then,
Yep.
so it'd be radical 13.
Nice job. See, that's all that's all I wanted. That's all I was looking for, and hopefully Mr. Barry got the exact same result. But yeah, nothing complicated, right? So now, how do I change -3, 2, which has a magnitude which is not equal to 1? So that's not equal to 1. How do I change it to something that does? Well, according to Miss Hamilton, I am going to multiply by 1 over that. And I will let you know that Math Excel is kind enough to you to allow you to write it just like this. In other words, it will not force you to rationalize the denominator. I'm definitely not going to ask you to rationalize the denominator because I think that that's too, let's see, how should you say it? Too extra. You don't need it. All I need to know is that you understand that you're dividing the components by the magnitude. That would be your vector. This has a magnitude of 1. And if you don't believe me, then go do the Pythagorean theorem on it, and you will find out that you do get 1. But that would be what you would want for Math Excel or a test in Math Excel. But yeah, not too bad. We've definitely this chapter will be a lot better than chapter 5 for those of you wondering, because there's a lot of geometry and stuff that you've already kind of based on. Now there's a notation that I want to show you because some upper level textbooks will use this particular notation. This is not my favorite notation. We will not be doing a lot of stuff with this, but you will see it in Math Excel for some questions. So what they're showing me is that they are calling the letter I a vector 1, 0, and a letter J a vector 0, 1. These are called standard unit vectors. So as you can tell, if you're going 1 unit to the right, that would be 1I. And if you're going 1 unit up, that would be 1J. So these basically represent your X and Y values. And I know some of you are going to look at me and go, well, that's kind of dumb. Why do they rewrite it? So in component form, if we wanted to change it to this other form, you're going to see it look like that. So if you started out with the component 3, 5, that's the equivalent of 3i plus 5j. Different notation, same exact meaning. 3i, 5j is still going to be 3 to the right and 5 up. So I know. Some of you are going to be like, well, why do we have to have it written twice? Well, that's just a different notation. You will see it. I'm not going to emphasize it, not going to major in on it. We're going to use the component form for most everything that we do. Just because I just didn't want you to look at it and go, what is this, imaginary numbers? No, it's not. It's just a different form of notation. Now, what if you were given the magnitude of a vector? Say the magnitude was 5, and the direction was 110 degrees. Now, on a graph, 110 degrees would look like this. That's 110 degrees. And a length of 5. There's two different ways we could figure out the component form. We could do... Now, I guess I should just ask you this question first. That's a right triangle. Can you tell me what the blue angle is right here? The blue one. Anybody know what the blue angle is? 70 degrees, right? 110 taken away from 180 gives me 70 degrees. Well, let's see here. If we call the bottom edge of that triangle X, and we call the left side Y, and we know it's a right triangle, how can we find X and Y? Doesn't this just take us back to SOHCAHTOA? What would you use to find X? Sine, cosine, or tangent?
Cosine.
Cosine. Excellent choice, sir. So we would have, let's see here, cosine of 70 degrees equals adjacent over hypotenuse. Okay, how do you solve that for X? Okay, I'll answer it. You multiply. All right, now, there's about 5 people participating out of 16. That's not exactly fantastic, folks. So, and I do understand there's some noise in the background on a few of you, and so that I do understand why you're not unmuting your microphone every 2 seconds. That I understand. But some of you, I'm not sure if you're listening, taking notes, or sleeping. I'm not sure. And I want you to be able to do this stuff, so I'm trying to help. So 5 cosine 70, what do you think we would have to do for the y value?
Do the same thing, but with sine.
Yeah, 5 sine 70. I've said and preached to you a million times, cosine is the x and sine is the y. The only reason we didn't need to multiply by anything is because we were dealing with the unit circle most of the time. But now we have a radius of 5 for this particular situation. Now, that answer that I just wrote down in green is wrong. Something about it is wrong. If you take your calculator and type 5 cosine 70, you'll get 1.71. And if you type 5 sine 70, you'll get let's just say 4.7. Yeah. What's wrong with that answer?
Can't cosine not be more than 1?
Well, I know what you're getting at, but you have to remember that we're not dealing with a unit circle. We had to multiply by 5 So we could definitely now have values. You're right. The cosine of 70 is not more than 1.
Mr. Staley,
Yep.
how did you, one more time, like, how did you get the magnitude?
I just made this up. Okay, so
Oh, you made
I chose a magnitude of 5 and a direction of 110, and so we're just trying to find the components. So
Okay, that makes
what's wrong with my answer at the bottom of the screen?
Is it decimal?
Nope. What quadrant am I in?
Oh, it's not in the second quadrant.
I'm in the second quadrant. So what's wrong with my answer?
One of the
X should be negative.
The x value should be negative. Thank you very much. The y value is positive, but the x is negative. So if you do it this way, you're going to have to make a decision on whether your x's and y's are positive or negative. Okay, so here's another way we could do the question. 5 cosine 110, comma, 5 sine 110. Now what happens when you type 5 cosine 110 on your calculator?
you get the negative.
You get the negative automatically.
Yes.
And you will get the, so there are obviously more than one way to do these questions, but if you use the triangle that I have kind of drawn out in green, you're going to have to use your brain and decide whether they're positive or negative. If we ended up down here in quadrant 3, you would have to make a decision that both your x value and your y value were negative. And if you're not getting those on your calculator, which is fine, because I understand, I kind of like to use the triangle myself, and then I just use my brain and go, oh yeah, this one's got to be negative and this one's got to be positive, or whatever quadrant I'm in. But pictures are important, so make sure you're drawing pictures to answer these questions.
Wait, so Mr. Staley,
Yep.
would you suggest using the first method where you use the angle like 70?
Yeah, I personally would use, because we get into some situations where it's just best, I'm, I draw a triangle and I draw that triangle, whatever quadrant it's in, and then I start looking at it going, okay, let's see, that one's positive, that one's negative, or maybe they're both negative. But if you focus on the triangle, it's just really pretty easy. You guys all know your Pythagorean Theorem. You know your inverse tangent. You know how to use that on a calculator. It's just a matter of deciding positives and negatives.
Okay, awesome. Thank you.
Yep. We don't need to do this question because we basically just did it. Well, why are they asking me for all 6 trigonometric functions? We've done find the components of the vector v with direction, angle 115, and magnitude 6 using no technology except to approximate the exact trig. That's the same thing we just did. Okay, so we don't need to do that example. Find the magnitude and direction of each vector. All right, let's do this one down here, which is a letter B. Okay, so let's see here. I'm going to do something interesting for us. I am going to split us into 2 different rooms, and then I'm going to join each room. One of the rooms is going to work on the magnitude, and the other one's going to work on the direction, and we're going to come back together and see if we can get an answer. So I'm going to, hopefully this works. If this doesn't work, you'll just have to join I've done this successfully once, and then actually successfully twice, and one time it kind of blew up in my face. So we're just going to see if this works. So I'm going to split you into 2 different rooms, and I'll join you in a second. If you don't hear my voice, just wait for me and I'll be with you. Let's see. That's good there. That's good there.
How do we know which group we're in?
You'll find out in a second.
Okay.
All right.
It prompts us to join, should we?
Yes.
Okay.
All right, ladies and gentlemen, you are finding the magnitude. The magnitude, okay?
Awesome.
All right, so you guys figure out what the magnitude is, talk to each other, and verify that you got the correct magnitude. And I'm going to go to the other room and tell them the wonderful news.
Or -2, -5. Then you just do like
Hello.
-2 squared. Oh yeah, the Pythagorean Theorem. Yeah. Wait, which one are we, Mr. Staley?
You are the direction.
Oh, well, we did that wrong.
We just found the magnitude though.
Hey, that's good. That's good. I like it. I
Are you
like
okay
it.
with that one?
No, you find the
We
direction.
found the magnitude.
That's great. Hold on to it.
Okay.
Then you can see if the other group's right or not.
Yeah, I can't see the question. I didn't
Okay,
write it
all
down.
right. So let me go back. Here's the question. Okay, so we got -2, -5.
Okay.
All right. You find the direction. I bet your angle is bigger than 180 degrees, okay? So when you do when you do your work, just make sure that your final answer for direction is bigger than 180 degrees. So I'm going to go check and see how the other group's doing, and then I'll be back.
Alrighty.
Hopefully I don't screw this up. That is not what I wanted. Whoops. Okay, more breakout rooms. Join. Yes.
You're muted, Mr. Staley.
I am? How did I get muted? Unmute. All right. So, what'd you guys come up with?
We came up with radical 29.
Yeah.
That's a horrible answer. No, I'm just kidding. That was great. Fantastic. 4 plus 25 is 29. You need a square root. I like it. Okay, hold on. I'm going to go see if the other group knows what the heck they're doing on direction.
All right.
Nice job, guys.
Thank you.
I don't understand this.
Okay, what do we not understand?
Is it -2 over -5 for the like tangent -1?
Hold on a second. So you got a triangle that looks like that.
Yeah.
And so you've got a -2 and a -5. And so when you do, because you're trying to find this angle in the triangle, that would be tangent,
Yeah.
tangent inverse -5 over -2, right? Opposite over adjacent. Okay, so when you do that, what'd you end up with?
Working on it. 68.2.
Yep,
Right?
that's
Yeah.
68.2. All right, now, how am I going to use that to find that angle?
Add that to 180.
Yeah.
Yeah, nicely done.
I think I figured it out. Maybe.
Well, you talk to each other here while I go to the other group.
248 plus, or 248.2. That's what I got.
Nice. Okay, now, the moment of truth is when I bring everybody back together, and hopefully this doesn't, like, let's see here, breakout rooms, close all rooms. Let's hope we all come back to the same room. I'm going to pray. Yes, it worked. All right. So what do we get for magnitude?
Radical 29.
Radical 29 is correct. Okay, we had 4 plus 25 makes radical 29. So that's our magnitude. All right, direction group, what'd you get? Or how did you do it, I should say? What did you do?
We took the inverse of tangent, the -5/2, or -2.
Yep.
And
Opposite
then
over
got
adjacent.
68.2, and then added that to 180.
Ah, good job. You got the 180 here, and then you went 68.2 degrees farther than that. That's why it's so important that we know what quadrant we're in. And what'd you end up with? 200 what?
248.2.
There you go. There's your direction. So, use the triangle, but then you need a picture to make sure you know which quadrant you're in. So, what are you going to do on this one right here? If we were to do 3, 2 and do the inverse tangent and find this little angle in here called alpha, what would we have to do to that in order to find its direction? You're supposed
Inverse tangent of 2/3.
If I did the inverse tangent, right? I got my inverse tangent of 2/3. I hit it on my calculator. Calculator tells me some angle, let's say it says 33.6. Okay? What do I do with that?
Add it to 0.
Okay, you guys keep saying add it to 0. That is, in the world of mathematics, that is hilarious. Okay? What does adding to 0 mean?
Then it's the same.
Exactly. You don't have to do anything to it. But just understand, the picture shows me. The picture is showing me what I need to do. And you're right. Sometimes I need to do absolutely nothing. Sometimes I have to do something because of the other quadrants. Good job, everybody. I like you're working together. We'll have to try that again. Maybe we'll split the rooms up into smaller groups. Okay. Now we need to talk about airplanes. They are using the bearing scale. Now the bearing scale, we've talked about it before, but we need to review, is different. So the bearing scale, which I'm going to draw on this circle down here, starts out 0 degrees due north. And it heads in a positive clockwise direction. So that would be 90, that would be 180, and that would be 270. Okay, then eventually you get back to the top. Your 360 and 0 are the same place. That is the bearing scale. This is what ships and planes use. Versus the unit circle that we've talked about a lot. Sine and cosine are all based on the unit circle. And so we'll have to go back and forth between these kind of at different times. So we need to understand how they work and go together. Okay, so we've got this aircraft flying at a bearing. Now, how do I know in a problem whether I'm dealing with the unit circle or bearings? Well, guess what? Every time it uses the word bearing, you're on the bearing scale. And all of your story problems are going to be using the bearing scale. So, I think you'll be okay. I think you'll figure out when it says bearing that that's what you're dealing with. Now, you can see that when it says a bearing of 65 degrees, they measured 65 degrees from 0 at the top. And the magnitude is listed out here as 500 miles per hour. So that's the length of the vector. Now it's true that we have a triangle here. And what's the angle inside the triangle? 25 degrees, right? So you got 25 in here, and you've got a length of 500 here. We need to be able to find out the components of that. Now they're both positive because we're dealing with something that looks like it's in quadrant 1 of the unit circle. So we don't have to worry about, any kind of negatives here. So how am I going to find the x and the y?
We could do
We're using cosine and sine, right? And yes, you're right, with the 500. Now, I want you to get into the lists of your calculator, list 1 and list 2 of your calculator. And so for those of us who don't remember that would be stat enter. If you hit stat enter, that'll take you to your lists. Okay? Now, it would be really useful if your lists were empty. So go to the top and hit the clear and the down arrow. Don't hit the delete key. If you've hit the delete key, I can help you get them back. Anybody accidentally delete their lists? Okay, that sounds like good news. All right. So in list 1, in the very first entry, I want you to type 500 cosine 25. And in the very first entry of list 2, I want you to type 500 sine 25. $500 cosine 25 and 500 sine 25. And hopefully you ended up with a vector of 453.15 and 211.31. Anybody not get those values?
Wait. Oh, yeah.
Okay.
I got 211.31.
You did not?
No, I got a very different. I didn't get the 195. The 195 one.
195. Where are we getting?
Wait, I got 195, not the 453.
Okay, go try that again. 500 sine 25.
211.
There you go.
Oh, we got that.
Okay. All right, now.
Oh, okay.
This particular question says that they want me to find the magnitude. Well, I mean, find the component form. So we've done that. We've found the component form. I'm going to add one extra thing to this. And yes, I'm making this part up because it's not part of the question. Suppose there is a wind. The wind is traveling at a bearing of 290. So the bearing is 290. So let me just write that down. Wind. And yes, I'm adding this to the question. Bearing 290. With a magnitude of 40 miles an hour. So we know that the length of that is 40. Now, what kind of triangle is that? Yes, I know it's a right triangle. Yes, I know the hypotenuse is 40. Do you know the angle that I'm highlighting in orange right now?
20.
That's a 20-degree angle, right? Because 290 goes 20 degrees past 270 on the bearing scale. Now, does everybody have things written down?
Yep.
Okay. Find the wind. Find the wind, okay? What is the component form of the wind? Before I split us all up into groups again, I want to know what the component form of the wind is. If I do, so what would I do with the 40 and the 20?
Do 40 cosine 20.
Okay. Now, I'm going to do this in my list 1 and my list 2. One of these is wrong. Which one is wrong? Is it?
List 1.
Yeah, because I have to put a negative in front of it. Okay, so in list 1, I want you to, in your second line of list 1, I want you to type negative 40 cosine 20. Negative 40 cosine 20. So that should be negative 37.59. And then in list 2, I'm going to type 40 sine 20. And that should be 13.68. Are we all getting those values? Or do we have them in list 1 and list 2?
Yep.
All right. So I'm going to split us into groups here, and the groups are going to be smaller this time. There are going to be, let's see here, how many rooms should we have? Options. Wait a second. I wanted, how do I do that? That is not what I was. I may not be able to do this as fast as I wanted to. Options. Oh, here it is. Let's see. We got 15. Yeah, we'll do this. That'll be great. Open all rooms. Well, it didn't work as much as I wanted it to, but we'll try.
Yeah.
All right, group. I need to know what is the final vector. You've got the plane. You've got the wind. I want the final vector, what we call the resultant vector of the plane plus the wind. So you figure that out. Are you there?
Yep.
All right. Now, I need to know what is the resultant vector of the plane and the wind when you combine them together. So, think about what you're going to do with the component forms of the wind and the plane. Talk to each other and see what you can come up with.
Would we just subtract them?
Talk to each other and see what you guys think.
Are we supposed to add them?
Talk to each other.
Negative 37 one? Yeah. Just do that and see what happens.
Wait, Staileys here. What do
Yeah.
we do?
Well,
Wait, we have, okay, wait, is this right, Mr. Staley? So would we combine like the two vectors, like the 453.15 and like the other number, and then the negative 37.59?
when you say combine, do you mean add?
Yeah.
You are correct.
Yes, let's go.
Right, because now remember I said resultant vector. We talked about that earlier, and that is adding, and so that's what you need to do. So you add them together and get the right values, and then I will bring us back together. I'm going to go see if the other group figured out what you guys did.
Okay.
Nice job.
Right, so let's add those together.
All right, what'd you guys decide was the best thing to do with the two vectors?
Just add them together.
Add them together is exactly what you need to do. Okay, so you work on that. I'm going to bring everybody back together here. All right, so everybody decided that they were going to add the vectors together. Now, the one thing I like about having the vectors in lists is I have everything on screen. So I can type 453.15 plus negative 37.59, and I can let the calculator tell me that the overall vector was, oh, come on, annotate, give me the right. The overall vector should have been 415 let's just say 6. And then the other one, 211.31 plus 13.68, gave me 220, well, we'll just say 225. Is that what we got?
Yep.
Okay. So, that's obviously because I added the extra part with the wind involved. Now, if someone is standing on the ground and they are looking up at this airplane, this particular airplane went basically 415.6 and then 225. So that's what happened to the airplane. Now you need to tell me the magnitude and the direction. I want magnitude and direction. Okay. And let's see here. If you are, let's go. If you are in, let's recreate all rooms. If you're in group 1, I want you to find the direction. If you're in group 2, I want you to find the magnitude. Group 1, direction. Group 2, magnitude.
Love that for us.
Right, why are we not getting the magnitude?
I
Mr.
thought
Staley need help.
help. Okay, so
Yes.
So which one did you have?
Direction.
Okay, so you got direction. So you're looking at your picture. You know that you've got side lengths of 415.6 and 225.
Yeah.
So you need to find this angle.
What?
How do you find that angle in the triangle?
Inverse of tan.
Yeah, inverse tan. Nice job.
Yes, so good.
Why? I sense a little sarcasm there. Okay.
It wasn't. I was serious.
Okay, all right, okay. But yeah, that's exactly what we need, inverse tan. So
So
you
the direction is always the inverse.
that's direction. Now, when I get back to the big group, we're going to also convert that to bearings because airplanes work on the bearing scale. So you can find the direction, but in a few minutes, I'm going to ask you for the bearing. Okay. See you later.
Bye.
All right, what'd you guys? What's going on with the old magnitude?
Isn't it okay? It's a big number, so it's like radical 223,348.36.
Yes. Now I can't find that on the. I bet I can't find that on the speedometer gauge of the airplane. So, do we have any thoughts on what it would actually read on the speedometer of the airplane?
472.5.
Yeah, nice job. Yeah, you're right. The 472.6. Well done. Okay, good job on your Pythagorean theorem. Okay, let's see if I can do this. All right. So let's see here. My magnitude group. Whoa, I need to fix that. Annotate. My magnitude group told me use the Pythagorean Theorem. And they did the 415.6 squared plus the 225 squared. And what'd you guys end up with?
472.6.
Okay, now, why does it make sense that the airplane is going slower than 500 miles an hour?
Because of turbulence. The wind.
The wind was pushing against. And since the wind is pushing against, it's slowing the plane down. That's why sometimes you get on an airplane flight and it takes a little bit longer to get there. And then there's other times where you get on the flight and you make it earlier than you thought. Why in the world would you make it ahead of time?
Because maybe the wind was in your favor.
Yeah, it's pushing you.
Wind pressure.
It's pushing you. It's pushing behind you, and so you end up with, you get to your destination faster.
Oh.
Okay, so how about my direction, people? What did you come up with when you inverted the tangent?
28.4.
Okay, so you had your 225, your y value over your x value, and then you got your what did you say? 28.4?
Yeah.
Okay, that's awesome for the degree measure inside this triangle right here, 28.4. Now, how the heck would I convert that to the bearing scale?
90 minus?
Yes, exactly. We got a 28.4 degree angle, and we're trying to find the bearing. If this is 0 and this is 90, you're right. We would take 90 minus 28.4, and what would we end up with?
61.6 or 56.
61. Yeah, we'll do 61.6.
Sure.
All right. That would be the bearing in that particular case. Any questions on those? Because I think that's the end of our notes. The last example is pretty much a duplicate, so I don't think we're going to do it. But any questions on this?
I'm good.
No.
I don't have questions for the notes, but I have a question for the Mac Excel. So
Yep.
you said that it's due basically after break,
Yep.
and that we should just wait till after break to like do it.
Yeah.
Right. Okay. Cool.
If you wanna do it today, you're fine doing it today. But I know most of you are in shutdown mode. I'm just thankful that you came for the notes today, and you've been participating. Now there is one cool thing I wanted to tell you about last before I let you go. Just as this just shows you some different bearings. When you guys watch movies, say like I would recommend on the break Hunter Killer. Great movie. Okay, it's about submarines, so it's a fantastic movie. But the other one that I kind of it's kind of a favorite of mine is Battleship. Have you guys seen Battleship before?
Oh yeah. That's
Okay.
a good movie.
Well, okay, in those kind of movies, they do things like they want to point the ship at a bearing of 060. So when they quote their angle measurements, they always quote them in 3 digits. Even if it's, so if they said 005, you would know that's a 5-degree bearing. So, but they always quote them in 3 digits. So when you're listening to movies and military movies or airplanes or ships, they will talk about bearings and they list them in 3. Now you'll know what they're talking about. I know. Helpful to all of your movie watching, especially over the break. Okay, so you're more than welcome to jump off the call. I will stay if there's any questions that you have. I chewed up a lot of time, more than I wanted to today, actually, but this is good for the other people. The kids that didn't join the call, they have a lot more to watch.
Like over an hour.
I know, it's an hour and 15 minutes so far.
Thank you very much, Mr. Staley.
Hey, have a good vacation.
Have a good spring break.
You too. See ya.
Thank you. Mr. Staley?
Yes.
So did you say the 6.1 Math Excel is not due until we come back?
Correct. It's not due until we come back on, I think I have it set for Tuesday night.
Do we have more notes though for
No,
this unit?
this unit is done on notes, but I knew that you can go ahead and do it if you want to, but you're not obligated to.
Okay, because I'm just home, so I'll probably do it.
Okay. All right. Well, it's open for you if you want to go ahead and do it. And then if you have questions, you can always